In exercise 3c, we will talk about hyperparameters maxstat, minbucket, and minsplit. A hyperparameter is a parameter that you have to set exogenously. In our case, this will be stopping criteria. So they should stop the tree from growing too much. We will vary them and see what its effect is and how that does influence the train and the test RMSE. So here I listed the descriptions of the three stopping criterions by the documentation. So minsplit is the number of observations that must exist in a knot in order for a split to be attempted. Minbucket is the minimum number of observations in any terminal knot, and maxstat sets the maximum depth of any knot in a final tree, with the root knot counted as stat 0. And we will discuss what this actually means. So let's start with varying minsplit. So I will set this to a very low number at first, which will be not restrictive. Because if you think about it, then if we set it, for example, to 2, then we say that as long as there are still 2 observations in a knot, we can split it. And basically this should always be the case, except for a knot with only 1 observation, then being the terminal knot. But as we still have other default settings that we didn't specify, this setting won't be binding and we won't grow a full tree. So this is basically still the same tree as under default settings, as another setting from the default setting is binding, as we specified this setting to be so low that it basically can't be binding. Why didn't we set this to 0 or let's say to 1? Well, it wouldn't make any sense, because if there is no or only one observation in a knot or in a region, then it doesn't make sense to split this region anymore. Because where should we split it if there's only one observation? So what happens if we run this? We will end up with the root, and I don't know why this is the case. If anybody knows this, or why this is specified as such, you can post it to DigiCampus. In the end, it wouldn't really matter, or it doesn't matter for you, because if you use a control setting, you want to set it such that it is binding, because this is the whole reason why you set it, because you want to control the tree from growing too big. And if you set it so low, then it will grow basically until there is an observation in a region for any observation. Okay, so what is binding? Well, these are the default settings, and this will result in this tree, and we don't see it binding yet. And if we have a look at the knots containing observations, then we will see that, okay, to have this criterion binding, or to have this tree being reduced in size due to our criterion here and not one of the default criterions, we will have to set this so high that it will be above the number of observations in one of our knots that is currently split. And if I do this, let's do it here. You will see that I specified this min split to be so high that it's exactly one above this this number here, which is the number of observations in knot number 7. And we will see that this knot number 7 or region number 7 is not split anymore, because now our stopping criterion binds and says, hold on, you don't have any enough observations here in this knot. This can't be split anymore, and we need to stop here. The result of this is a shorter tree, or a tree with less splits, and an increase in the RMSEs, so a worse performance, because we don't fit the data as good anymore as we reduced complexity and therefore introduced bias, which we can see in a increase in both train RMSE and test RMSE. Okay, so let's go to the next part, which is min-bucket, which works very similarly, but this time we won't have a look at the observations in the knot that is splitted or is split, but the one we split into, okay, or the ones we split into, so the terminal knots in the end. So this says, min-bucket says, it's the number of observations in any terminal knot. So if we set it to 1, this will be least restrictive, because even if we would grow the tree into its largest possible form, so that there's one observation or there's one region for every observation, then this will still be fulfilled. There will still be one observation in every region. So this is not restrictive, and therefore it will end up in the same tree as under the default settings, because now we are still only restricting by criterions that we didn't specify here, and they are still set to the default level. So what will happen if we now set it to a level where that is above a terminal knot, and I just grabbed a random terminal knot here. Let's see, this is this one. So knot number 12 is a terminal knot indicated by the star, and it has 7,810 observations in it. So if that is if it's above this level, then this split, or the splits these terminal knots stem from, cannot be performed anymore, or that's not allowed. So let's have a look how this looks like, and we will see that indeed the above split did not, or the above knot did not split anymore, but also other splits didn't occur, which also violated the criterion, because there are more terminal knots that did not have this amount of observations. So there are several splits that did not occur anymore, and this leads to a very high in-sample and out-of-sample RMSE, so very bad performance and high bias. If we compare it, for example, to the defaults RMSE and in-sample and out-of-sample RMSEs. So let's come to the last stopping criterion, which is, or that we have a look at least, which is max depth, which is pretty straightforward. And I will just run for these four numbers, or these four values, the whole tree. So first of all, we have max depth to 3, and this will lead to the default tree, or the tree under default settings. Now if we lower it to 2, then this will restrict the tree. And now we can see what I mean by levels or depth. So think about every node, every of these nodes being on a vertical line, a horizontal line, and starting with 0 at the top. This is depth 0. Then this is depth 1. This is depth 2, and this is depth 3. So if we set depth to 3, then we will be allowed to grow the tree until this depth, but no further. If we set it to 2, we can only grow it until here, and so on. If we set it to 1, we can only grow it to this level, and this also results in the in higher RMSEs. So here you see roughly 1400, here 1700, or between 16 and 1700. Then here 2500. And now if I set it to 0, I would expect only to the root to be there, but it is specified, or this function is specified such that the maximum depth must be at least 1. So we cannot reach a sole root node prediction by setting max depth to 0, unfortunately, as it is hard-coded into the library that we must have at least a value of 1 when specifying max depth. Okay, so these were 3 stopping criterions for growing the tree.